Okay, so I'm going to just cover the tangent part of this section. So we're going to start with the parent graph for the tangent function, which is right here, okay? And I've got a unit circle over here. I don't have everything filled out. I just have the important parts that I need for this, to get my critical points here, okay? So remember, when you're looking for tangent, on the unit circle, that's going to, since it's opposite over adjacent from any place, that's going to correspond to the y over the x, okay? Because the y would correspond to the opposite and the x would correspond to the adjacent, okay? So I've got these different values in here, and so I'm thinking, okay, if I'm at negative pi over 2, well, that puts me down here, right? And then so, hey, here's my x and my y. So when I'm down here, y over x is going to equal negative 1 over 0. Okay? But you can't have 0 as a denominator, so that means that this is undefined. Just put a dash or undefined, okay? So let's look at negative pi over 4. When I'm over here, here's my x and my y, so I'm thinking y over x again. And that would be root 2 over 2 over, this should actually be negative root 2 over 2. It didn't print out right there. Okay, so I've got a negative root 2 over 2 over positive root 2 over 2. So I have something over its opposite, which means that's just going to be negative 1. Okay. When I'm at 0, y over x here, I'll just do that like that because I don't have much space. But my y is 0 and my x is 1. So 0 divided by 1 is 0. Okay. Up here, y over x, got root 2 over 2 over itself. Anything over itself equals 1. Okay, and then finally up here, if I do y over x here, I've got 1 over 0. Anything over 0 is undefined. So there's my critical points. And 2 of my critical points aren't actually points. So here, let me scroll down a little bit so we can start graphing this, okay? So let's take this table and start plotting these points. So what I'm going to do with the undefined parts, those are like they are asymptotes, okay? So since when I'm at negative pi over 2 on this graph, since it's undefined, that means there can't be any points on my graph that have a theta coordinate of negative pi over 2. Same thing at the bottom of the table at pi over 2. Those places are both undefined, okay? So I often refer to these as my goalposts. So everything is going to be happening between these goalposts. So let's see, negative pi over 4, negative 1, that would be right here, okay? 0, 0, the origin, and then I've got pi over 4, 1, okay? So this is going to be a sort of an S-curve that's going to go through these 3 points. And it's also going to use those goalposts as guides for the curve. So here's how it's going to look. It's going to look something like this. Okay? So, you know, my lines will, my curve there will never touch the goalpost, but it'll get closer and closer to it, to that asymptote there. Okay? And this is just one cycle of the tangent function. So remember that this pattern would continue on forever. So if I extended, I just put 1, 2, 3, 4 more ticks, there would be another goalpost out here, and there would be 3 more points, and that pattern would repeat. Typically, we're just going to graph one cycle, which is the part I have in green here. But just remember, this pattern is going to repeat itself, okay? All right, so if we're graphing, so that's my parent function. That's really important to know, okay? But if I'm graphing the reciprocal of this, I'm not going to go through making another table. I'll just cut to the chase. It's going to look a lot like my last graph. So I'm still going to have goalposts at negative pi over 2 and positive pi over 2. But the 3 dots in the middle, instead of going uphill from left to right, they're going to go downhill. So this is going to be a reflection over the theta axis, which is going to result in my curve, my S curve, going the opposite direction, kind of going downhill instead of uphill like that. Okay. All right. One thing that is super important about the tangent function that gets messed up a lot has to do with the period. So remember, the period is the length of one cycle. Period equals length of one cycle. Okay, so for this graph, some people are going to look and say, oh, the cycle ends at pi over 2, so the period is pi over 2. Well, that's not true, because we've got pi over 2, that's this distance, but then we've also got another pi over 2 happening because over there, because that distance is also pi over 2. This stretches from 0 to negative pi over 2. So when I put those together, pi over 2 plus pi over 2, it's going to be 2 pi over 2, which is pi, right? So the period for tangent for the parent graph is pi, okay? And that means when we're looking for on other functions, this is the parent graph, but anytime we're using tangent, when we're looking for the period, we're going to use pi over k. Okay? For sine and cosine, we use 2 pi over k, but we're not going to use that for tangent. Okay, so let's try graphing some tangent equations. So this process is very, very similar to graphing sine and cosine. Two big differences are just what the parent graph looks like, and then also the period. So the base period is pi, not 2 pi. Okay, so anyway, so here we've got this equation. So the amplitude is 3, right? That's just right there. So there's my amplitude, okay? Vertical shift is right here. This is my vertical shift. So -1 or down 1. Okay? And then for the period, pi over k, not 2 pi over k. Okay? And the k is the coefficient that would be between tangent and theta. It doesn't matter if it's inside the parentheses or not. K is 2. So in this case, I'm going to have pi over 2 for the period. Okay? Phase shift, I still take the contents of that the parentheses and set it equal to 0. So I'm going to say theta minus pi over 4 equals 0. I'll add pi over 4 to both sides. So this means I'm going to be going right because my phase shift is positive. Okay? I'll try to focus this a little bit. Okay, and the last thing is to graph this. All right, so let's start by, I'm going to graph the ghost first. Okay, actually, I'm going to start with the road map. So I'm going to use the vertical shift down 1. So here would be my midline. I'm doing this very lightly because the road map kind of gets in the way a little bit with tangent because we've got lines going this way and it just gets a little convoluted. Okay, and then the amplitude is up 3, so I'm going 1, or it's 3. 1, 2, 3. I'm going up 3 from that midline and also down 3. 1, 2, 3. Just doing this very lightly. So my critical points are going to be on these 3 lines, just like they would be with sine or cosine. Okay, but the parent graph looks different. So you're going to have, for the ghost, I'm doing this lightly again. I'm going to have a point there, a point here, and a point here. Okay? And if this had a reflection, if it had a negative, then that would be flipped like this. Okay? And then my goalposts, my ghost goalposts, are going to be the next 2 points out. Okay? All right. So this is what it would look like if there were no phase shift. Okay, if I didn't have the minus pi over 4 in there. So let's scale the axes, okay? And it gets a little tricky with the period because it's tempting to say that hey, this is gonna, that my period is pi over 2, so hey, this is the end of my cycle, so this would be pi over 2. But that's incorrect, okay? Pi over 2 is the distance, that the length that the whole thing takes, but it's centered on the y-axis. So that means I'm going to have half of the pi over 2 to the right and half of it to the left. So there would actually be a quarter pi on each side of this, because then I'd have 2 quarter pi's that make up a half pi. Another way to handle this, the fourth tick is always going to correspond to the period. Okay, so just like with sine and cosine, my fourth tick is whatever the period is. So this is going to be pi over 2. Okay, and then that means, you know, halfway to pi over 2, this would be pi over 4 then. Okay, and we can scale the rest of the axis in the same way. Halfway to pi over 4 would be pi over 8. Now I know every tick is pi over 8. Okay. So then I'm going to use the phase shift. Remember, this means that I'm going to the right, and I'm going to the right pi over 4. And now looking at my scale, I know that means pi over 4 means 2 ticks, right? Pi over 4 is 2 ticks worth. So I'm going to take this whole thing and shift it 2 ticks to the right, okay? So I'm just going to take, I like to just take the goalpost on the left and shift that. So I'm shifting this 2 ticks to the right, which puts it right on that left goalpost. The left asymptote is right on the y-axis, okay? And then I'm going to use the pattern on the road map that I've got there. So I've got my 3 points like that, okay? And then the last goalpost is going to be out here, and I can draw in the actual curve. It'll look something like that, okay? Okay, so I want you to always label where your cycle ends, which I have the pi over 2 here, and where it starts. You don't really need to label the y-axis because we can see that that's 0, but if you wanted to, that would be 0, right? Okay, so let's try another. Okay, next problem. So the amplitude is always positive, so that's the 4. Okay, now this tells me, hey, we're going to have a reflection. So the shape of this one, rather than being an S-curve that goes upwards, the basic shape is going to be like that. It's going to be going downhill, okay? All right, amplitude is 4. Vertical shift comes from here. This is the vertical shift. So up 1 or just 1. Okay, the period, I'm going to use pi over k. In this case, k is 2. So I've got pi over 2. That's my period. Okay, and then phase shift, I'm taking the whole, taking all of this and setting it equal to 0. So I'm saying 2 theta plus pi equals 0. A lot of people just say, oh, I take the opposite of that, so it's negative pi. No, the 2 is going to affect the phase shift, okay? So I'm going to subtract pi from both sides, and then I'm going to divide by 2. Okay, so my phase shift is going to be negative pi over 2, or pi over 2 to the left, if you want to think of it that way. This is going to go left. Okay, all right. So let's start by plotting our little road map. So the vertical shift up 1. That is my midline, just doing this lightly. And then I'll use the amplitude. I'm going to go up and down 4. 1, 2, 3. Oh, I didn't make enough ticks here, so I need one more tick there to get the top of this graph in. Okay, and then 1, 2, 3, 4. I went down like that. Okay, all my critical points are going to be on the road map here. Did I count right? 1, 2, 3, 4. 1, 2, 3, 4. Okay. So, all right. With tangent, there's my first critical point. And since this is going downhill, I want to make sure that I put a point up here and down there. Okay? And then I'll frame that with the goalposts on the next tick out. Okay, so this is what the ghost would look like if I wasn't, if there were no phase shift. It would look like this. Okay, of course we do have a phase shift, but it's still worth plotting the ghost so we know what it looks like and we can shift that left and right. And also it'll help to scale the theta axis, which is really important because we've got to figure out how many ticks to go to the left. Negative pi over 2, that doesn't really mean anything to me right now until I get this theta axis scaled. Okay. All right, so I'm going to do that with the period. The period, just like on the last problem, is pi over 2. So that's going to correspond to the fourth tick. This will be the fourth tick. Is the period always, okay? So fourth tick out here, that is going to be pi over 2, okay? And then halfway to that would be pi over 4 and so forth. But actually, that's enough for me to do the phase shift. So now I can see, okay, that means 4 ticks. Pi over 2 means 4 ticks. So I'm going to go 4 ticks, left 4 ticks. Okay, so let me take this leftmost goalpost. 1, 2, 3, 4. Here's where the asymptote on the left is going to go. Okay, and then I'm just going to follow them. You could take the points one by one and move them to the left, but I like to just use the left goalpost and then do the pattern from there. I just think it's quicker. Okay, and the right goalpost is going to end up where the left one was from the ghost. Okay, so there it is. And I also want to label where this started and ended. Okay, so hey, 4 ticks to the right is pi over 2. So let's see. I guess I do need to scale this a little bit. If I want to go 2 ticks, then would be pi over 4 because that's half of pi over 2, right? So now I can count. Hey, 2 ticks to the left. This would be negative pi over 2. Get this out of the way there. Okay, and then let's see. So I'm just going to count by 2s, and I know each 2 is. Sorry, this is a quarter pi, not a half pi to the left, because it's 2 ticks. Okay, so this is 1 quarter, 2 quarters, 3 quarters. I'm kind of counting by 2, right? So because each 2 ticks is a quarter, so 1 quarter, 2 quarter, 3 quarters to the left. So this would be 3 pi over 4. Okay, and then I've labeled where this starts and finishes, right? Where my 2 goalposts are. Okay, and that's it for today. See you next time.